In this problem, we have a 15-foot ladder leaned against a wall, and the bottom of the ladder is sliding away from the wall at a rate of 5 feet per second. We want to find the velocity of the top of the ladder at time t equals 1 if the bottom of the ladder is 4 feet away from the wall at time t equals 0. Okay, so there's my base of the ground and my building or the wall. So my ladder is going to be green today. Okay, and it is a 15-foot ladder. The length of the ladder does not change, so we can go ahead and label that as 15. Now the bottom of the ladder is sliding away, so this point is moving out in this direction. Okay, it's sliding away. When it does, the top of the ladder is going to fall down the wall. Okay, it says the bottom of the ladder slides away from the wall at a rate of 5 feet per second, which means that this distance between this base of the ladder and the edge of the wall is increasing at a rate of 5 feet per second, which means we need to give it a variable name. So I'm going to call that x, and then we can say that dx dt, the rate at which x is changing, is positive 5 feet per second, and it's positive because x is increasing as the base of the ladder is pulled away from the wall. Now we want to find the velocity of the top of the ladder at time t equals 1 second if the bottom of the ladder is 4 feet away from the wall at time t equals 0. So we'll come back to the 1 second part, but the point is that we want to find the velocity of the top of the ladder. At this point in time, that's what we're interested in. That is, we want to find how fast is the top going down the wall. So we need a variable for the distance between the top of the ladder and the wall, because what we want to find is the rate at which y is changing. That would be how fast the top of the ladder is sliding down at the moment when t is 1 second. Okay, changed my colors there. That's okay. Alright, so that's what we know, that's what we want, and we now need an equation relating x, y, and 15. But luckily the Pythagorean theorem is a nice simple equation that relates those variables. Okay, I'm going to go ahead and differentiate implicitly at this step, but you could solve for y first as well. So taking the derivative of both sides with respect to t will give me 2x times the derivative of x with respect to t plus 2y times the derivative of y with respect to t, and that's because both x and y are functions of time. So they're both changing with respect to time, and the derivative of 15 is 0. So now we want to solve for dy dt, and I know dx dt. I'm going to need x and I'm going to need y at the moment when t is 1. Let's do this over here. We're going to need x and y when t is 1. Now it says the bottom of the ladder is 4 feet away from the wall at t equals 0. So the bottom of the ladder starts at 4 feet away. So what I'm going to do is draw a snapshot of this situation at the moment when t is 1. So this is like a picture of how it's changing because I've got variables labeling my quantities that are changing. Now I'm going to draw a picture of it at the moment when t is 1 and label all of the fixed values here. So at 1 second, if the bottom of the ladder is 4 feet away from the wall at 0 seconds, and then the bottom of the ladder is sliding away from the wall at a rate of 5 feet per second, then this bottom of the ladder has slid 5 extra feet in that first 1 second. So that distance is going to be 9, because it started 4 feet away, went an extra 5 feet away in that 1 second. So we need to find y still at the moment when x is 9 and the diagonal is 15. Again, we can use the Pythagorean theorem for that. So 9 squared plus y squared equals 15 squared. So y is equal to the square root of a large number there. Let's see what that comes to. So 15 squared minus 81 for 9 squared comes to 144, which is a nice perfect square. So y is equal to 12 at that moment. Okay, so now I'm going to plug in everything that we know over here and solve for the unknown. So we have 2 times x at the moment when t is 1, x is equal to 9, we just found. dx dt is positive 5. That's 2 times y is positive 12. And dy dt is what we are solving for. So that equals 0. So let's see, we have 40 times 2. So my first term is 80 plus 24 times dy dt equals 0. So 24 dy dt equals negative 80. So dy dt is negative 80 over 24, which I'm sure reduces a bit here. So let's see, that would be just dividing by 2 is negative 40 over 12. We can write negative 20 over 6, or negative 10 thirds would be the exact value. And we are in, it looks like, feet per second. So that's the speed at which the top of the ladder slides down the wall. Now, it's negative because y is decreasing. So let's go over to this problem in the homework system and take a look at it. It says negative 3.75 is the exact value, although the numbers may have changed. No, the numbers are the same. Good. Okay, but you can see I made an error somewhere because negative 10 thirds is not the same as negative 3.75. I went back and looked at it, and all I did was right here. 9 times 5 is 45, not 40. So this is actually 90. So that will become negative 90. When we do negative 90 over 24, that's the same as negative 45 over 12. And at some point we just need to approximate. Just approximate there, it looks like. Since we're going to approximate anyways, when you do 45 divided by 12, we do get the negative 3.75. And in here they do want you to include the negative, it looks like.